Hello everyone, myself Dr. NCH Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to today's session on normal distribution part 4. In the last session, we have discussed some problems on normal distribution. If the values of x and z are given, if x and corresponding z are given, how to find the mean mu and standard deviation sigma. Similarly, sometimes if z will be given, mu and sigma will be given, then find the probability of x lies between any two values or greater than a given value or less than a given value. So, to find that, we convert this x to z, the standard normal variate, using the formula x minus mu by sigma, and then we calculate the area from z lies between two values using the standard normal distribution table. So, such problems we discussed in the last class, and we will continue the same today also. Coming to the present problem, the marks x obtained in mathematics by 1000 students is normally distributed with mean 78% and standard deviation of 11%. So, the given data is mean mu equal to 78, 0.78 and standard deviation is 0.11. Now, the question is to determine how many students got above 90% marks. So, more than 90%. So, the first question is to find probability of x greater than 0.9. So, here x is the normal variate and z is the corresponding standard normal variate. And how to transform this x to z using the formula x minus x bar. So, how to find this z? X minus mu by sigma. This is the standard normal variate. And now, we need to calculate the number of students who got above 90%. So, we need to calculate the number of students. To find that, first we need to calculate the probability of students who got above 90%. So, that means x greater than 0.9. So, if x equal to 0.9, what is the value of, that implies what is the value of z? So, 0.9 minus 0.78 by 0.11. So, which results as 1.09. So, to find the probability of x greater than 0.9, we need to calculate z greater than 1.09. So, that means 1.09 to infinity f of z dz. So, if you draw this graph, this is this particular point is 1.09. We need to find this region from 1.08 to infinity. But we cannot find this using the standard normal distribution table. Using the table, we can calculate only from 0 to that point. So, we know that this half area is equal to 0.5. So, total 0.5 minus area from 0 to 1.09 f of z dz. So, using the standard normal distribution table, this value is given by, using the standard normal distribution table, this value is given by 0.3621 and hence the final answer is 0.1379. So, this is the probability of students who got like greater than 90%. But we need to calculate the number of students. The number of students who got greater than 90% is 0.1379 into the total number of students, 1000. So, 137.9, which is approximately 138 students got more than 90%. Similarly, we can calculate the second, what was the highest mark obtained by the lowest 10%. So, the second one, what was the highest mark obtained by the lowest 10%. So, lowest 10% means they lie in the left tail of the distribution. So, this 10% students, this is 0.1. So, this is 0.4. So, this is some Z1 and or Z2. So, here this Z2 will be negative value. So, the area from minus Z2 to 0 is equal to 0.4, which is same as the area from 0 to Z2 is 0.4. Just now we have calculated. So, Z2 is 1.28 with negative value, negative sign. So, Z2 equal to minus 1.28. And now we need to calculate this, what is the highest mark obtained by the lowest 10% students. So that means here we have this Z2 value as minus 1.28 and Z formula is x minus mu by sigma. So which is in the given problem you have 0.78 and 0.11 given. So x minus 0.78 by 0.11 and here minus 1.28 is x minus 0.78 by 0.11. So what is the value of x? If z is minus 1.28, what is the value of x? That we need to calculate. So this x will be 0.6392. So that implies 63.92 is the minimum mark, is the maximum mark obtained by the lowest 10% of the students. So 63.9 is the maximum. What was the highest mark obtained by the lowest 10% students? So this is the highest mark obtained by the lowest 10% student. Now coming to the fifth problem, a sales tax officer has reported that average sales of the 500 business that he has to deal with during a year is 36,000. So the given data, the average mu is 36,000 with a standard deviation of 10,000, sigma is 10,000. Assuming that the sales in these business are normally distributed, find the number of business as the sales of which are more than 40,000. So that means we use the standard normal distribution and the standard normal variate is given by x minus mu by sigma. So x minus 36,000 by 10,000. And in the first question, probability of x greater than 40,000 is the required one. So if x equal to 40,000, what is the value of z that we need to calculate? Then z is 40,000 minus 36,000 by 10,000, which results as 0.4. And that means to find the probability of x greater than 40,000, we calculate the probability of z greater than 0.4. So z greater than 0.4 means 0.4 to infinity f of z dz. So which can be obtained by subtracting area from 0 to 0.4 from 0.5. So which results as 0.3446. And the question is the number of business as the sales of which are more than 40,000. So we need to calculate the number of businesses. So the number of business is equal to 0.3446 into 500. It results as 172. Similarly, the second question lies between 30,000 and 40,000. So probability of 30,000 less than x less than 40,000. So first we need to transform this x equal to 30,000, this x equal to 30,000 to z and x equal to 40,000 to z. So using the formula z equal to x minus mu by sigma, where mu is given in the problem 36,000 by 10,000 sigma. So here 30,000 and 40,000 will be converted to standard normal variable value using this formula and results as, if x equal to 30,000, z equal to minus 0.6 and x equal to 40,000, z equal to 0.4. So to find the probability that x lies between 30,000 and 40,000, we need to calculate the value of z lies between minus 0.6 and 0.4. So that means the area from minus 0.6 to 0.4. So minus 0.6 to 0 plus 0 to 0.4, and this negative portion is equal to corresponding positive portion. So 0.6 to 0.4, and using the table we can calculate this 0 to 0.4 and 0.6. So in the second question, the percentage of business the sales of which likely between 30,000 and 40,000. So area from 0 to 0.6 and 0 to 0.4 can be calculated using the standard normal table, and this answer is 0.3811. Here the question is not to find the number of business. Here we need to find the percentage of business. So therefore 0.3811 into, so required solution or answer is 38.11. And coming to the next problem, determine the mean and standard deviation of a normal distribution in which 7% of items are under 35 and 89% are under 63. So this is another important model. Determine the mean and standard deviation of normal distribution. So we need to calculate what is mu and what is sigma. We need to calculate mean and standard deviation. And what is the given data? 7% of items are under 35. So under 35, 7% of items are there. 7% means less than 0.5 and the values are under 35. That means that lies on the left side, so negative portion. So I can consider this as 7%, 0.07, 35. Less than 35, 7% of items are there. That means the remaining portion, this will be 0.43. Is it clear? So what is the given data? 7% of items are under 35. So let us consider this 35 here, x equal to 35. 7% of items are less than that 35 value. So 0.07 lies to the left side of this x equal to 35, and here this is 0, and we know that this area, left side area, will be equal to 0.5. 0.5 minus 0.07 gives 0.43. So if x equal to 35, what is the value of z that we need to calculate? Z1, we know that it is negative because that lies on the left side. So minus Z1. And what is this negative value that we need to calculate? We have the formula z equal to x minus mu by sigma. We don't know the values of mu and sigma. But if x equal to 35, for x equal to 35, area from minus z1 to 0 is 0.43. This is the data from this graph. The area from minus z1 to 0 is 0.43. And since the normal curve is symmetric, the negative portion is equal to corresponding positive portion. That means the area from 0 to z1 is also 0.43. Then what is the value of z1 from the normal distribution table? This we need to calculate. So if you use the normal distribution table, now let us find the value of z corresponding to the area 0.43. So here this value is nearby 0.4, 0.43 we need. So 422, here 4292, 4306. So this is the value 1.48. So the area from 0 to z1 is 0.43. So using the standard normal distribution table, we can calculate this z1 as z1 equal to 1.48. So we have the area, and so that we can obtain the value of standard normal variate. Similarly, another information is given, 89% are under 63. So let us consider 89% means which is greater than 0.5, 89%, that means 0.89, greater than 0.5. So obviously the value will be positive. So this is 63. So this total area is 0.89, and we know that this half area will be 0.5. So this area will be 0.39. That implies the second one, x equal to 63. For this, area from 0 to 63 is 0.39. Again, use the standard normal distribution table, and in the reverse manner we can calculate the corresponding value of z also. Here this z2 will be positive. Why this z2 is positive? Since the area to the left side of that z value is greater than 0.5, it should be a positive value. If the area left side to that z is less than 0.5, that must be a negative value. So here Z2 is positive. Now again use the same thing from standard normal distribution table. Z2 will be 1.23. So in the standard normal distribution, let us find the value of Z for which the area is approximately equal to 0.39. Hence the Z2 is given by 1.23. Now what is the actual thing to find? Here the question is to determine the mean and standard deviation, because mu and sigma are unknown. So we have the formula Z equal to x minus mu by sigma. That implies Z into sigma is x minus mu. So mu plus sigma Z is x. Now first one, if x equal to 35, what is the value of Z1? 1.48. So x equal to 35, then Z is 1.48. So mu plus 1.48 sigma is 35. This is equation number 1. Similarly, if x equal to 63, the value of Z is 1.23. 63, Z is 1.23. So let us substitute these values here. We get mu plus 1.23 sigma is x equal to 63, and here this Z1 is negative value. Z1 is negative, so minus 1.48. So this is minus 1.48. So here we get minus equation number 2. So solving 1 and 2. These 1 and 2 are system of equations in 2 unknowns. So 2 equations in 2 unknowns. By solving these 2, we can calculate mu and sigma as, so by solving 1 and 2, mu is 50.3 and sigma is 106.75. A similar problem is given here. Determine the mean and standard deviation of normal distribution in which 31% of the items are under 45, 31% of items are under 45. So that means under 45, which is 31%, which is 0.31 less than 0.5. So obviously that value must be negative. So corresponding Z will be negative, minus Z1. So 31%, 0.31. So this will be 0.19. Similarly, another information, 8% are under 64. 8%. 8% are under 64. So again, the person under 64, the probability or the values are 8%. So again the same. In today's session, we discussed some problems on normal distribution, and here x denotes the normal variate and z denotes the standard normal variate. In normal distribution, we have different types of problems. If x values are given, we convert them into z and then we find the probabilities or areas under the standard normal curve. Similarly, sometimes if z values are given, we have to calculate x using the standard normal variate formula x equal to z equal to x minus mu by sigma. Sometimes both x and z will be given, we need to calculate the unknowns mu and sigma. So these are different varieties of problems, and in the next session we will solve some more problems on normal distribution.